finish 13.2. I'm just going to swipe up. This will be problem 4 and problem 5. Okay, so the trinomial that we have is x squared, a positive 6x, and a negative 40. It tells us to factor the trinomial. A method that we learned is doing the AC method. I'm going to do this first one. I'm trying to think. No, yeah, I'm going to do this first one using a slightly different method that if you understand and you can use it properly, that's great. If you can't, the previous 2 videos show the actual entirety of the AC method. I do just want to allow you to have this shortcut in your pocket that you can use. Okay, so remembering our rules, not really rules, but the steps of the AC method. I'm going to swipe up here, identify A, B, and C, multiply A, B, and C, right? So keep this in mind right here. That wasn't the right color. Keep that in mind right here, that we multiplied A and C, right? So that means we were looking at a product. Then we also needed to choose a pair that could combine to our B, right? So there's 2 stipulations that have to be true when doing the AC method. The fact is that we have a product that we got from multiplying A and C, and they also combine together to equal our B, right? That's going to comprise our shortcut. So it's going to look a lot different than what we've done, right? What you do for this shortcut could also be called like trial and error, because you could attempt it and then like foil it and then learn that, hey, that actually didn't work, and try it again. So you go through trial and error. I know that because this is a 2nd degree trinomial, just like with here, I ended up with 2 factors because I started with squared. Ended up with 2 factors because I started with squared. You see a pattern here. If we don't do it in 13 actually, I don't think we did it all in chapter 13. If you move forward, that's the goal, to go to college algebra. If you do factor something and say it's cubed, then you would have 3 sets of parentheses, right? So they match. I know for a fact that I'm going to end with 2 sets of parentheses. Well, let me move these down just a tad. I also know that once I do factor a trinomial, if I wanted to check myself, haven't I told you could go back and FOIL, right? You can multiply the 2 binomials together. If you get back to the original trinomial, then your multiplication was correct, and that multiplication came from these 2 these 2 factors, which means your factors are correct, right? So AC method shortcut, trial and error. Because this is x squared, and if I multiplied, I would do this times this. Don't I get back to x squared? Yeah, so this is going to be the best method to use if you could wrap your head around each step properly, and only when your A is 1, okay? Now let's look. I need to fill these 2 spots right here with numbers. Now the 2 stipulations are that is that they multiply together to give me A times C, right? The same product. And that they combine to give me B. So what we can do is go ahead and come over here. A is 1, B is 6, C is negative 40, right? A times C would give me a negative 40. So that's what I'm looking at. Okay, so what 2 numbers multiply together to give me 40, and at the same time, a negative 40, y'all, and at the same time can combine together to give me a positive 6. So just think about the number 40, right? I know 2 and 20, 1 and 40. I know if I multiply 4 times 10, I get 40. Because it needs to be a negative 40, one of those needs to be negative. I know I'm trying to also combine to a positive 6. So if I do this, y'all look at those two numbers I just filled in there. Do you agree with me that if I multiply them, I get negative 40? And do you agree with me that if I combine these together, right, that's a positive 10 and negative 4, I would subtract, keep the sign of the larger, and I get my B? You're done. Go back and FOIL it. You'll get back to the original trinomial. So still like a thought process, still has some work that goes into it, but you're not listing every factor. You're not having to expand your B. You're not having to factor by grouping. Do you see what I'm saying? Like, it literally cut out the majority of this step and this whole middle step right here, okay? There's no shame in your game if you have to factor by the AC method. The trial and error will not always work. Mainly, I recommend it if your leading coefficient is 1. If it's a 2 or a 3 or a 4 or a 5, don't do it. You will go down a rabbit hole, okay? I'm going to do our fifth and last example for chapter 13, section 2. This one I believe is important. It's 6x squared, got a positive 18x, negative 60. Can I do the trial and error? No, that first number up front is a 6. I don't want to do that. I do kind of see a trend though, right? If I look at my A and my C, those are both divisible by 6. 6 divides 6, 6 divides 60. I wonder, does 6 divide my middle term? It does. Y'all, that's a greatest common factor. They all can be divided by 6. So just like the first section in chapter 13, we're going to pull out the GCF and then we could do the trial and error. Now, I need to know if they share any common variables. 2 terms have an x, but not all 3 of them, so they don't have an x in common, right? So right here, I just go ahead and divide. Well, 6 divided by 6 is 1. Signs are the same, so it's positive. X squared divided by no x squared. Y'all, when I say that, it's x squared divided by 1, right? And that's just x squared. So what you'll hear me say is x squared divided by no x squared. Divided by no x is just going to equal x squared. Then we do 18 divided by 6 is 3. Signs are the same, so it's positive. X divided by no x is just x. 60 divided by 6 is 10. Those signs are different, so it's negative. And then that's it, right? Now I notice that what I have here is a GCF and I have a trinomial. Well, even though this is out by itself, it came from the original trinomial. So you need to make sure that if you pull a GCF out before you factor, it will be included in your answer, okay? Okay, let me see here real quick. I had to pop my fingers. So I'm going to bring down my GCF and I'm going to trial and error this, okay? I know, I'm trying to get a pretty color here. I don't really have one. I know that my A is 1, my B is 3, my C is a negative 10. I know that if I do A times C, I'm going to get a negative 10, right? So the two things I'm trying to satisfy is that they multiply to give me a negative 10 and they combine to give me a 3, right? A positive 3. Well, think about the different ways you can get to 10 using multiplication. 1 and 10 and 2 and 5. Like, that's literally it, right? So I'm thinking I'm going to lean towards the 2 and 5. First, what I need to do is put my x's. Those came from x squared. Okay, if I multiply those, I get back to x squared. Now, if you agree with me, I kind of like this as my option. The only other option is 1 and 10, and I know they don't have a difference of 3, right? So 2 and 5 need to multiply to a negative 10, which means one of them needs to be negative. Well, they need to combine together to give me a positive 3. I'm pretty sure if I do a positive 2 and a negative 5, I won't get a positive 3. I would get a negative 3, right? But if I do a negative 2 and a positive 5, I will get a positive 3. So that ends up being the combination that I want. And then that's your final answer. If you wanted to go back to check yourself, you could FOIL these and then distribute your 6 in. Okay. And that's it, y'all. That finishes 13.2. If you have any questions, make sure y'all email me, okay? Thanks. Bye.